Hello, today I'll introduce RMCD, Relevance-aware multi-context contrastive decoding, a decoding method that more effectively leverages multiple retrieved context for retrieval-augmented visual question answering. In RAG-based visual question answering, we retrieve relevant documents from an external knowledge base to complement the missing knowledge that cannot be covered by the model itself, and we feed those documents into an LLM to generate an answer. This is especially important for datasets like InfoSeq, where a large portion of questions are difficult to solve without external knowledge. However, there is a key issue. Even if we retrieve multiple contexts, they're not equally useful. Some contexts directly support the correct answer, while others are only weakly related or completely irrelevant, which can actually confuse the model. In other words, simply adding more context does not reliably improve the performance. Therefore, our goal is to leverage multiple retrieved contexts in a relevance-aware manner. In existing MLLM-based RAG, contexts are often treated almost equally, so truly helpful contexts are not sufficiently reflected, while irrelevant contexts can lead the model toward wrong answers. As illustrated by the yellow curve on this slide, increasing the number of contexts and baselines does not always yield consistent gains. To address this, we propose a solution at the decoding stage. The first step of Rmcd is simple. We use the retriever's retrieval scores to compute a weight for each context. We assign a large positive weight to highly relevant contexts and a small weight to less relevant ones. And moreover, for contexts that are clearly harmful, we even allow negative weights to those contexts so that their influence can be actively subtracted. The second step is to aggregate the model's output losses from each context using those weights. Intuitively, predictions from good contexts are emphasized, while predictions from poor contexts are downweighted, and with negative weights, they are effectively cancelled in the opposite direction. Importantly, Rmcd is a decoding method applied only at inference time with no additional training. Here are the quantitative results. Simply replacing the baseline decoding with Rmcd consistently improve accuracy across multiple knowledge-intensive benchmarks, including InfoSeq, Encyclopedic VQA, and OKVQA. Another important point is that Rmcd is not tied to a specific model. It can be applied broadly to various types of MLLMs. Rmcd also has advantages in terms of efficiency. Using the same number of contexts, Rmcd improves accuracy while keeping latency similar or even reducing it. And because it requires no extra training, the deployment cost is very low. In other words, we can obtain gains purely from decoding without retraining the retriever or the model. Next, we analyze performance under different retrieval qualities. As the knowledge base grows, retrieval becomes harder as the proportion of irrelevant document increases. In such settings, retrieval noise becomes severe and answering correctly is more challenging. Even then, Rmcd consistently outperforms other decoding methods, both when retrieval is strong and when it's weak. That is, Rmcd is robust to retrieval quality and achieves the best performance across the board. We also consider an extreme oracle retriever setting, where the ground truth document is always retrieved at rank 1. Even in this case, Rmcd provides additional improvements. This indicates that Rmcd does not only fix issues caused by imperfect retrieval, it also better exploits helpful context and suppresses harmful ones, achieving improvements that are orthogonal to retriever enhancement. The qualitative results also support the same intuition. Relevant contexts receive high weights, so the necessary information is reflected more strongly in the answer, while confusing contexts receive negative weights, which suppresses or cancels the probability toward incorrect answers. To summarize, existing MLLM-based RAG often fails to account for the relevance of retrieved context, which leads to underutilizing helpful information and being distracted by irrelevant information. To address this, we propose Rmcd and show that it improves performance across various models and benchmarks by fixing the decoding process only, without any additional training. Thank you for listening.